Got to give the people, get the people what they want. People want their homework. We got two more types of factoring. All right, so we've been working on the factoring last class. Now we got two more types, and we're about to put this all together. It's about to be figgity fantastic. So first, you all talked about the difference of squares, but there's a thing called the sum of squares, right? So for example, if you get 4x squared plus 16, those are two perfect squares. All right, so we're really just going to do this like a difference of squares. So we're going to rewrite the original equation as a difference of squares. So 4x squared plus 16 turns into 4x squared minus negative 16, right? So now we have a squared minus b squared, which works out to a plus b times a minus b. That's the difference of two squares. And we've seen that already. But notice, now that we have imaginary numbers, we can actually take the square root of a negative number, this negative 16. We can actually take that square root. Where before, maybe like, well, I can't do the square root of negative 16, so this doesn't work. All right, so let's put this into action. Go ahead, we have 4x squared minus negative 16. So we have to do the square root of 4x squared, which is 2x, that's our a term. And we have to do the square root of negative 16, which is our b term, right? And just to remind ourselves, square root of negative 16 is the square root of 16 times the square root of negative 1. And the square root of 16 is 4. The square root of negative 1 is I. So our b term is 4i. This is all stuff that we've done, so I'm going through it pretty quickly. So now, since we could do that, I know it's just a plus b times a minus b. 2x plus 4i times 2x minus 4i. Why don't you go ahead and do this example on your own right now? Cool, you paused, you did it, you were like, oh, okay, I got this. So I'm going to rewrite it, x squared minus negative 36. Now I have a difference of two squares. I know that a is x and b is root of 36 times square root of negative 1, which is 6i. b is 6i. So now I just go, oh, I factor this. It's a plus b, x plus 6i times a minus b, x minus 6i. Done and done. Factored. Boom. Let's keep it moving. The last type of factoring we're going to talk about is, well, what if I have a fourth degree trinomial? Okay? So, if you have a polynomial that is 3 terms and the leading term is 4th degree and the middle term is 2nd degree, then you can try to factor it just like a quadratic trinomial. All right? So, let's first talk about how this is. So go ahead, and in the start, I'm going to have to rename my variables. So go ahead and write down this example. So for example, if we have x fourth times x squared minus 20, right? Notice the leading term, 4th degree, yes. The middle term, 2nd degree, yes. It is a trinomial, meaning there are 1, 2, 3 terms. Yes. Then I might be able to factor it this way. So, notice I'm saying I'm going to need to rename my variables. This is the hardest part. Notice, this is x squared. I'm just going to call that q. And notice that x squared times x squared is x to the 4th, right? So it's the relationship between x squared and x to the 4th. X squared would be x squared times x squared, which is 1, 2, 3, 4, which is x to the 4th. So if I square this piece right here, I get this piece right there, right? So if x squared is q, then q squared is x to the fourth. I have to see that. If I take x squared and square it, I get x to the fourth. So if I call x squared q, if I take q and square it, I should also get x to the fourth. It's a little bit confusing, but hopefully after you see it, you'll be like, yeah, I got this. So let's talk about what do I actually do with that. So I'm going to rewrite my variables. So instead of calling this x to the fourth, I'm going to call it q squared. I got it from right here. Minus, instead of calling this x to x squared, I'm going to call it q. So q squared minus q minus 20. That's what I'm going to factor. And we know how to factor that. Factor this for me, please, using the area model. Cool. You just did that. You were like, this is easy work, Bass. Boom, boom, boom. This is q squared. This is negative 20. I know these middles need to add up to negative 1. And I know they need to multiply to whatever 1 times negative 20 is. So they need to multiply to negative 20. I got this. This is easy work. Multiply to negative 20. Add to negative 1. 4 times 5 is 20. 4 times negative 5 is negative 20. And 4 minus 5 is negative 1. Cool. So I get a 4q and a negative 5q. I say, okay, this is q times q. This is q times 4. This is q times negative 5. Boom. So I end up with, oops, not x, q minus 5 times q plus 4. Well, now I'm going to go back to what I said. But what does q actually stand for? Q is x squared. So this actually equals x squared minus 5 times, what is q? It's q is x squared. Don't forget, I'm looking up here. X squared plus 4. Let's just go ahead and check to see if that works. Let's see, does this actually equal this? So let's multiply it. Easy work. Boom, 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 boom. X squared minus 5, x squared plus 4. This is x to the fourth. This is minus 5x squared. This is 4x squared. This is minus 20. X to the fourth. Put those like terms together. That's minus 1x squared minus 20. Does that match? X to the fourth minus 1x squared minus 20. It matches. Boom, bow, surprise. All right. Do one on your own. Why don't you go ahead and rename these variables, please? So, this is the one I want to rename first. Call it anything we want. I'm going to call it h. H is going to be equal to x squared. So that makes h squared equal to x to the fourth. See, this became h, this became h squared. Now why don't you go ahead and finish this? Cool, you did it. So you had h squared minus 2h minus 3. Easy work. Boom, boom, boom. Oh, I said h and wrote x, didn't I? H squared minus 2h minus 3. So h squared minus 3. They need to add to negative 2. They need to multiply to negative 3. 3, negative 2, 1, 3. 1 times negative 3 is negative 3. 1 minus 3 is negative 2. Easy work. 1h, negative 3h, h, 1 minus 3. Cool. Cool. So I end up with h plus 1 times h minus 3. And then, remembering that h is actually x squared, so I end up with my factorization, x squared plus 1 times x squared minus 3. Because remember, h equals x squared. Oops. Should have put it to the right place. H equals x squared, as we said up here. Boom. That is it, Mr. Bass. I'm out.